So hello everybody, this is Shivam Rajput back again with a new video on a video series of CSI Earth Sciences. So today, on a special request of you guys, I'm going to cover Milankovitch cycle and its relation with climate change. Now this particular topic is very important. In CSIR also they relate this Milankovitch cycle with climate change and ask various questions in part C. By the end of this video I will solve various questions based on this particular topic. So be there with me till the end of this video and we'll cover everything regarding the same. So let's start. The first question over here is what is Milankovitch cycle means? So this Milankovitch cycle is basically describes the collective effect of Earth's movement on the Earth's climate over thousands of years. So here the Earth movement is nothing but the change in the Earth's orbit, the change in Earth's axial tilt, and the third one is the change in axial direction. So this is the change in the Earth's orbit, that is called eccentricity, change in the Earth's tilt called obliquity or tilt, and change in the Earth's tilt direction, that is called precision. I will show you animation regarding the same, then it will be really easy for you. So this is the NASA website and here you can see that the first thing is called eccentricity. So over a 1 lakh year, the Earth's orbit changes from circular to elliptical. So less circular, it's not completely circular, but less circular to elliptical. Okay. Is this clear? And you can see that the eccentricity is varying between 0.034. Check the value over here. It is 0.034 to 0.058. So this is the value, the range in which the Earth's orbit will turn into elliptical then towards circular. So this 1 lakh here is basically a difference between circular to elliptical then circular. Okay, it's not circular to elliptical, it's from circular to again circular. Okay, is this clear? So this is called eccentricity. Now let's see the second one called obliquity. So here we can see that over a 41,000 years the Earth axis tilted from 22.1 to 24.5. Okay, so this is the range. Again 22.1 पे जाएगा. So always remember this obliquity is again 22.1 to 24.5 and again 22.1. So again it's a whole cycle, the whole oscillation. This is called obliquity or axial tilt. Okay, change in the axial tilt. So this is the range in which these values varies. Okay, the third one is called precision. So over a 26,000 years the direction of tilt changes. Okay, currently it is facing towards a star called this thing polar, and uh, after some 13,000 years back it is facing towards Vega, a star called Vega. Okay, is this clear? So I will discuss this in detail. So let's start this with eccentricity first. Here in this diagram we can see that the eccentricity of Earth is changing with time. Okay, now eccentricity is denoted by letter E, small e. Okay, so basically this eccentricity measures how elliptical an orbit is. Okay, a planet which is closest. So let's assume right now, let's assume this elliptical orbit. Okay, now here we can see that this point is this position of Earth is closest to the sun, while this position is farthest from the sun. Okay, so this position is called perihelion. This point is called perihelion, and this position when a planet is away from the sun at the farthest distance from the sun, then it is called aphelion. Okay, in a case of Earth Sun system, sorry, Earth Moon system. This is Earth Sun. No, in a case of Earth Moon system, let me see any photo if I have. No. So what I am doing is, let's make another circle over here. Okay, here we have one moon. This is our Earth Moon system. Okay, so in a case of moon, if moon is closest to the earth, then in that case the point is considered as perihelion. So suppose this is the closest point. Okay, so this will be considered as perigee, not perihelion, it's perigee. At the farthest point, it is called apogee. Apogee. So this is the difference. Perihelion term is used for sun earth system, yani star planet system, but perigee term is used for earth moon system, yani planet satellite system. Similarly, aphelion for this, aphelion. Okay, and apogee term is used for this, aphelion for this. Okay, is this clear? Now over a 1 lakh year, the orbit changes from nearly circular to elliptical, then again circular. Okay, now how to find eccentricity? They may ask some numericals based on this. So eccentricity, that is small e, denoted by small e is equal to a minus p by a plus p. Okay, this is the formula. What is a? A is called aphelion. A is called aphelion, the farthest point, aphelion, and p is what? Perihelion, the closest point. Okay, now from this formula, when E is equal to 0, that means what? E equal to 0, that means A is equal to P. If A is equal to P, then E is equal to 0. And when A is equal to P, when it is nearly circular. So in a case of circle, suppose this is circle, the radius is always same, so there is no aphelion and perihelion, all points are at equal distance. In that case, E is equal to 0, that means orbit is circular when eccentricity is equal to 0. As E gets close to the 1, the orbit becomes more elongated. If E is closer to the 1, then it becomes more elongated. And when E is greater than 0, so we can say that now the orbit is not circular, it is now elliptical in nature. The orbit is elliptical. Here we can see that this orbit is elliptical in nature, right? So here the eccentricity is greater than 0. Always remember that Sun is not in the center of this ellipse, and according to Kepler's first law also, all planets revolve around the Sun in a elliptical orbit, where Sun lies at one of the two foci of ellipse. या तो Sun यहाँ हो सकता है और या तो यहाँ हो सकता है. But the Kepler's law has one limitation. Kepler's law बताता है कि in any case Sun is either over here or over here, or orbit is always elliptical. But according to Milankovitch cycle, after 1 lakh year, this circular turns into elliptical, and again elliptical turns into circular. Yani at each 1 lakh year, the orbit is no more elliptical in nature. So there is no two foci. Point to be noted over here is this clear? Okay, moving to the next, that is tilt, axial tilt. So eccentricity, clear? Remember this formula, it's very important for numericals. Okay, now before learning about this axial tilt, let's see this photo, it's very important. Now we are considering the orbit is elliptical and the sun is not exactly at the center, which is let's see, it is somewhere here. To make you understand, sun is in the center, but in reality the thing is not like that. Sun is either over here or here, one of the two foci. So let's assume, okay, right now this point, this particular point is called summer solstice. Okay, sorry, this position is called summer solstice. Okay, here we can see that at this point sun incident angle is at 90 degree, and this line is called Tropic of Cancer, TOC. Okay, so sunlight at 21st of June is incidenting at 90-degree angle, okay, on Tropic of Cancer, and this position is called summer solstice position. Okay, summer solstice. Okay, summer solstice. While when sunlight incident on the Tropic of Capricorn, that is 23.5 south, at 90-degree angle, then the position is called winter solstice. Why summer and winter solstice? Because in northern hemisphere we have summer, so summer solstice. In northern hemisphere in December of 21st of December we have winter, so we consider winter solstice. So basically, since most of the countries, advanced countries, developed countries are in the northern hemisphere, even all the scientists, most of the scientists, genius scientists जिन्होंने ये बनाया था system, they are from northern hemisphere, so they are considering the seasons according to the northern hemisphere. So northern hemisphere में we have winter, that why winter solstice. Here in the northern hemisphere we have summer, then it is considered as summer solstice. But always remember, if there is a summer in the northern hemisphere, that means there is a winter in the southern hemisphere. So याद रखना, on 21st of June there is a winter in southern hemisphere, that is Antarctica, Australia, Southern America, Africa, all these regions, the lower part of Africa, not the entire region. Okay, lower part, which is in the southern hemisphere. Okay, is this clear? Now एक क्वेश्चन पूछ सकते हो कि वाई सनलाइट इंसिडेंटिंग only at 23.5, why not 24 and 24, 25, 26? Why not some other latitude except Tropic of Cancer? It is all because Earth is currently tilted at 23.5 degree angle. Okay, so अभी Earth कितना tilt है? 23.5. That's why sunlight can maximum reach up to 23.5 north and 23.5 south after 6 months. So there is a 6-month gap, no, between these two regions. This is called equinox position. Equinox is what? When sunlight incident exactly at the equator. So at that point of time there is a 12 hours of day and 12 hours of night. Here in the summer time in the northern hemisphere daytime is more. देखो, this line where this side we have lighted region, this side we have dark region. This is equator. Let me clean this. This is our equator. Okay, this is the dark region and this is the light region. So in the northern hemisphere you can see that in the northern hemisphere the lighted part is more, so daytime will be more in the northern hemisphere. In summer we know that daytime is more than night time, while the night time is less. In the southern hemisphere we have winters, and winters may we know night time is bigger, so night time is more than daytime is less. Is this clear? Similarly over here winters may in northern hemisphere daytime will decrease and night time will increase because winters are going on. Okay, is this clear? While on equinox positions, that is 21st of March and 21st of September, at that point the daytime and the night time will be same because sunlight is incidenting exactly over the equator. So 12 hours of day, 12 hours of night. Is this clear? Now this will help you to understand axial tilt. So what is axial tilt means? It is also known as obliquity. Obliquity refers to the tilt of Earth's axis relative to the plane of its orbit. So relative to the plane of its orbit, it is tilted 23 and half right now. But it is never be the same. It varies between this 22.1 to 24.5. In between these values, the tilt will change. Okay. In December, the axis is tilted away from the sun. In December, it is tilted away from the sun. Okay, the axis is tilted away from the sun. Sun se dur hai. That's why in the northern hemisphere we have winters because it receives less energy from the sun. Because of this angle, it is away from the sun. The northern hemisphere is away from the sun. The this line is what? You tell me what is this line? Comment. Jaldi comment karo. This is called Arctic Circle and this is called Antarctic Circle. 66 and half north, 66 and half south. Now Arctic Circle is completely in the dark condition right now. That's why sea ice will form over here. Full Arctic ice formation will take place. Sea ice will formation will take place. While over here you can see the entire Antarctic Antarctic circumference. Okay, so this Antarctic circumline is now away from the sun, completely in the dark. That's why full Antarctica will freeze during 21st of June, somewhere close to this time. Okay, so pole is completely in dark, and after 6 months this is completely in night, and that's why we say that on poles we have 6 months of day and 6 months of night, because for 6 months it is under the dark condition, for the 6 months it is under the light condition. Clear or not? Now remember, it's not the distance which matters, which change the season, it's a tilt which change the season. Now the closest point, this is 21st of June, right? Here somewhere here we have January, and on 3rd of January sun is closest to the earth on 3rd of January, and on 3rd of June here we have 21st of June, right? So somewhere here it is the farthest point. So this is called aphelion and this is called perihelion. July में 3 जुलाई को it is at aphelion position and this is your perihelion position. The difference in the distance will be around 5 million kilometer. So you can say that January में earth is 5 million kilometer closer to the sun, while at 3rd of July the earth is 5 million kilometer away from the sun. Now you can ask कि अगर जनवरी में if earth is 5 million kilometer close to the sun, then why we have winters? So the answer is it's a tilt which cause season. It's not the distance. Yeah, because of distance there have some less intensity line. Yeah, 6% intensity कम हो जाती है. Okay, during aphelion condition, and 6% intensity will increase during perihelion. Okay, that is considered, but it never be the reason for change in seasons. Okay, I hope this is clear to you. Now the question is, what happen if the obliquity becomes 0? Right now it is 23.5 degree tilted. Let's assume this is the orbit, sun is over here and earth is like this. No angle with this, no angle. Right now 23.5. Let's see, it is now shifting to this direction. If the obliquity becomes 0, there would be no season at all. So again we have like this situation. Photo में बनाया ना. So the both hemisphere will receive same amount of sunlight. So in that case there would be no season. Distance from the sun is not the factor for determining the season. It's not the distance. It's not the perihelion and aphelion. It's a tilt. Remember, always remember. It's also a previous year CSIR question. Okay, clear or not? Okay. Now the timing between this 22.1 to 24.5 again 22.1. So this is the cycle, and this cycle will take 41,000 years to go from this to again this. Always remember, it's not this to this. 41,000 year is the cycle from 22.1 to again 22.1. Is this clear? Chalo. Now this is all about obliquity. Our next question, our next thing is precision. What precision means? So precision is basically change in direction of tilt of Earth's axis. जो अर्थ एक्सिस का टिल्ट है इसी का डायरेक्शन चेंज हो जाए. Currently our earth is pointing towards Polaris star, but some 13,000 years back, why I am using 13,000 years? Because the whole cycle is 26,000 year long. So from Polaris to Vega and again to Polaris will take 26,000 years. So half of it will be what? 13,000 year, 26 का. So आज से कुछ 13,000 साल पहले the Earth's tilt axis is pointing towards a Vega star, a star in our celestial sphere. वो पॉइंट कर रहा था वेगा की तरफ. ओके 13,000 साल पहले. सो देख रहे हो फोटो, यहाँ देख सकते हो. सो हियर वी हैव लॉट्स ऑफ स्टार्स नो इन स्पेस. द क्लोजेस्ट स्टार इज सन, नो डाउट, बट say in outer space we have a star called Vega. So as I said 13,000 years back, the tilt direction is pointing this side. Right now it is pointing this side. So it keeps changing. So अब तुम ये बताओ. Right now the tilt direction is somewhere like this. So let's see. मानते हैं कि Polaris is somewhere here. So tilt is facing towards this Polaris. Okay. But 13,000 years back, Vega is over here, and in that case, the tilt of Earth is not like this. Instead of that, the tilt is something like this, 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 this. So, because of this tilt change in the tilt, some 13,000 years back, our northern hemisphere in June is pointing away from sun. Right now it is facing towards the sun, but 13,000 years back it is facing away from the sun. यानी simple language में in June in India we have winters. 13,000 साल पहले winters होगा. क्यों? क्योंकि now earth is not like this. Earth is like this. इस तरह से अर्थ है. You got my point? Got my point or not? I will show you some photos. Wait. So see, it is pointing towards Polaris. 13,000 years back it is pointing towards the Vega. This is your Polaris, this is the Vega. 13,000 year gap. Okay. अब इस क्वेश्चन से समझते हैं, then it will really help you. ये देखते हैं, देन बताओ. सो विच टिल्ट सिनारियो प्रोड्यूस ग्रेटेस्ट सीजनल कॉन्ट्रास्ट? विच टिल्ट? ओके ओके ओके. सो ये देखो, इफ देर इज नो टिल्ट देन देर इज नो सीजन. मैंने बताया था इट्स अ 0 डिग्री एंगल. ओके, इट्स अ 0 डिग्री एंगल. सो देर इज नो सीजन. हियर इन दिस केस द नॉर्दर्न हेमिस्फीयर इज पॉइंटिंग टुवर्ड्स द सन. बट 13,000 साल पहले क्या होगा? द नॉर्दर्न हेमिस्फीयर इज पॉइंटिंग अवे फ्रॉम द सन. सो इन दिस केस से इट इज जून टाइम. In June, in northern hemisphere we have summers, and in the southern hemisphere we have winters. But 13,000 years back, in the northern hemisphere we have winter, in the southern hemisphere we have summer. It's just opposite. It is the month of June. Okay. Here we have summer, here we have winter, while here we have winter, here we have summer. It's the tilt direction which matters. Okay, now ये question actually obliquity से related है. Now it's your time. You tell me which of the following has greatest seasonal contrast. We have different tilts. Okay, you tell me A, B, C, D, E. Just comment section में just comment करो जल्दी. Pause the video, think about it, and you tell me where we have greatest seasonal contrast. Seasonal contrast means what? Intense summer, intense winter. The difference of the season is called seasonal contrast. Okay, agar throughout the year we have same type of season, then there is zero seasonal contrast. Okay, so no doubt this will has least seasonal contrast while E is having maximum seasonal contrast. So the maximum tilt leads to maximum seasonal contrast, because now we have this is what, this is polar region, this is Arctic, this is Antarctic. So Arctic is fully melted because it is exactly pointing towards the sun, while it is exactly in the opposite direction. So here we have intense freezing, here we have melting, here we have freezing. After 6 months, this part will now face towards the sun and this part is now away from the sun. So here we have again freezing and again melting. Okay, you are getting this point. One part is truly towards the sun. So अब देखो यहाँ क्वेश्चन ये आ सकता है कि right now the tilt is 23.5 current tilt. Say in future tilt will increase. मानते हैं कि अब 23.5 से it is shifting towards 24.5. What will be the change in the season? So in that case seasonal contrast will increase, and if the tilt will decrease, seasonal contrast will decrease. Are you getting my point? So इस point से I proved how the change in season took place. So always remember 13,000 years back the northern hemisphere is having winters in June and southern hemisphere is having winter in December. Here we have summers, here we have summers. Got my point? It's opposite. Okay. Now here, how does precision affect seasonal contrast? Okay. Given the orbital configuration shown below, which is approximately today's configuration, which hemisphere has high seasonal contrast? So let's solve this question. Okay, now this is the orbital plane. From orbital plane it is tilted 23.5. No, okay, 23.5. Question में पढ़ो ना. Given the orbital configuration shown below, which is approximately today's configuration. So in today's configuration, in June, this is December, the northern hemisphere is pointing towards the sun, and here the southern hemisphere in December is pointing towards the sun during December month. Okay, now we have to discuss which hemisphere has high seasonal contrast. Seasonal contrast will be more in which hemisphere? Okay, pause the video, give me the answer. Okay, so the right answer over here is the southern hemisphere. Why? The southern hemisphere has summer when we are slightly closer to the sun. We know this is 21st of December. So here we have January, and we know perihelion point is in January. So sun is closest during January. Don't go with the photo. Photo mein this point is closer, but in reality January is the closest point. Okay. In July we have at the farthest point, July में 3 जुलाई को, right? This is called aphelion. So we can say that the southern hemisphere has summer when we are slightly closer. So यहाँ देखो अभी summer है, and here we are closer to the sun. And in southern hemisphere we have winter when we are farther from the sun. So based only on the solar radiation which is coming in, I told you no, there is a difference in solar radiation by 6%. At perihelion there is 6% more radiation. At aphelion there is less 6% radiation. So based on the solar radiation coming in, the southern hemisphere has high seasonal contrast than the northern hemisphere. Is this clear or not? It is having. Now let's discuss another question. To grow an ice sheet, what kind of seasonal contrast would be the best? High seasonal contrast, hotter summer and colder winter, or low seasonal contrast, coolish summer or warmish winter. And the third one is, it wouldn't make any difference. To grow ice sheet, we know that some 20,000 years back we have ice sheet, we have last glaciation maxima, LGM is there. Why there is a ice sheet at that point of time in the northern regions of northern hemisphere? The whole Canada, America, Siberia, Russian region is covered with the ice. Why? It's all because of Milankovitch cycle, and this Milankovitch cycle is keep repeating, right? The eccentricity is having 1 lakh here, the tilt is having gap of 41,000 year. For the precision it is 26,000 years. So there is a certain period after which the tilt, the obliquity, the eccentricity varies, and in this way the total radiation reaching the earth's surface is changing. Okay, because of the radiation variation, the total heat budget will change, and it will cause ice ages. Sometimes it cause glaciation, sometimes it cause interglaciation. Okay, so here give me the answer, which is the correct, A, B or C? In the comment section, give me right now. Okay, so I will discuss. The correct answer is B. Low seasonal contrast is required for ice sheet. Now I will tell you why. In northern hemisphere, if we have say low seasonal contrast, because there would still snowfall in the warmest winter. देखो यहाँ क्या लिख रहा है, warmest winter. Winter is there, but it is warmish in nature. Okay, but during summer is coolish. देखो समर कूल होने का मतलब क्या है, उतना इंटेंस गर्मी नहीं होगा. वार्मिश विंटर का मतलब क्या है, उतना इंटेंस ठंडी नहीं होगी. Okay, so the intensification of summer season and winter season is not there. Okay, so because there would still a snowfall in the warmish winter, even if it is a warmish winter, there is a snowfall, and even if there is a summer, it is coolish in nature. Coolish in nature means what? There is no more melting. So सोचो, ऐसे सोचो. Suppose this is the northern hemisphere. Here we have Arctic ice. This is Arctic ice. If the summers are hotter, in that case the Arctic ice will melt. अगर summer बहुत ज़्यादा hot है, say the northern hemisphere is towards the sun, say 21st of June time. Right now the northern hemisphere is towards the sun. Sun is over here. Okay, so it is pointing towards the sun. So now the Arctic will feel summer. Okay, so during summer time the Arctic ice will melt. If the summer is hotter in nature, during winter time, here again sea ice freezes. So in this way the amount of heating and the amount of freezing is more or less same, unless and until we put more carbon into the atmosphere. That carbon will again start global warming and all, so that we are not considering over here. But again you can see that during the hotter summer what happened, the sea ice will melt, and during the colder winter it will freeze. But in the second condition देखो, coolish summer. So even if the summer is coolish in nature, there is less melting. Melting is there, but less melting. So suppose during winter, say 100% ice freezes, the entire region is freezes. Okay, but in summer not melt 100% because summer is coolish. So it will melt only say 55% of snow ice. only 55% sea ice melt करेगा, not the entire. Again during the winters, the there is snowfall. I know this is warmish season, but still there is a snowfall. So this 55% will again reach to say 100%. Again there is a less melting, so 55 will reach to now 65. Why I am increasing this way? Why 55 is not 55 in the next year? Why it is again increasing to 65? It is because of ice albedo effect. Okay, ice albedo effect. एक फीडबैक भी होता है कॉल्ड आइस एल्बिडो फीडबैक. Let's see how. Suppose 55% of ice is there in summer in Arctic region. Okay. Now this 55% of ice will start reflecting sunlight to the atmosphere. Since ice is having high albedo. High albedo is what? It is now reflecting more than absorbing. Okay. So if radiation is going out of the earth, then there is a decrement in the temperature. So temperature will decrease. Temperature will fall down. If there is a fall down of temperature, this 55% will become 56%. The snow ice will more, it will enlarge, no, simply it will enlarge. The coverage area will increase because temperature is going down, because the albedo is there. Now 56% is now further reflecting more. So it will act like a positive feedback. What is positive feedback? When there is a direct proportion relation. So one leads to increase of other, or one leads to decrease of other. So decrease leads to decrease, increase leads to increase. अगर आइस को बढ़ाएंगे then there is more increase in reflection. So क्या हो रहा है देख रहे हो ना, there is a direct relation. एक चीज को बढ़ाने पर दूसरा चीज बढ़ रहा है. If there is more ice, there is more reflection, and if there is more reflection, then temperature will fall down. So fall down होगा तो क्या होगा? The coverage area of sea ice will increase. 56, then 57, then 58. That's the reason why over a time, over a period of time, over some 100 years to 200 years, the entire ice sheet will form over there. ऐसा form होने लगेगा. That's the reason why we have a snowball earth period. Snowball earth period था, right? Somewhere close to Paleozoic period. In the Paleozoic, we have snowball earth. Why? Entire earth is in under the ice coverage. क्यों? It's all because of ice albedo feedback. तो क्वेश्चन ये आता है कि ठीक है, जब पूरी तरह से कवर था अर्थ, then why right now we have global warming everywhere? Why there is ice somewhere close to the high latitude and high altitudes regions only? Because over a period of time there are also volcanoes. So in past there are volcano, जब भी वो फटते थे, in at that point of time lots of greenhouse gases were emitted, and that starts increasing the temperature. So again then we have feedback effect. Okay, so if there is more CO2, there is more absorption. More absorption means more melting of sea ice. More melting of sea ice means less reflection of sunlight. Less reflection of sunlight means more absorption of sunlight in the atmosphere. More absorption of sunlight in the atmosphere means more increase of global temperature. And again this more increase in global temperature leads to further melting. Further melting leads to further less reflection. Less reflection leads to less more absorption. So in this way it is like a chain reaction. Okay, अगर तुमको ये चीज़ अभी समझ में नहीं आया तो स्पीड को थोड़ा कम करो, 2 बार सुनो, समझ में आ जाएगा. Okay, so here I will discuss this. Okay, this feedback effect, ice albedo feedback. So देखो, the low seasonal contrast in the northern hemisphere, so not all the winter snow will melt away in the following summer. The entire snow will never melt, and in this way slowly with time this ice coverage area will increase, and after a threshold the rate of increase is very high and it leads to the ices. Okay, so because of this perturbation more area is covered with ice and snow. If more area is covered means more reflection from the earth's surface. More reflection from the earth's surface means less absorption of solar energy. Less absorption of solar energy means temperature will fall down. and if the temperature will fall down, again it will increase the, it is favorable condition for more surface area for ice cover. It will increase the rate of sea ice formation, right? So this will lead to this will lead to this, and over a period of years, say 100 years, it will slowly increase the entire coverage of sea ice. You are getting my point? So this is called ice albedo feedback. Got it or not? Here, on the basis of this Milankovitch cycle, we can see that the total incoming solar radiation is not same over a time. Sometimes it is more, sometimes it is less. Let's give you some examples. अभी बताया था eccentricity. Sometimes we are close to the circular, sometimes we are close to the ellipse. If you are circular, that means at throughout the year, the solar radiation will be the same. But if it is elliptical, for a certain periods of month, we have more solar radiation than for certain months. But at the same time, एक चीज और देखो, when we are close to the sun, the orbital velocity will increase to counter the sun's gravitational force. So that means when we are closer to the sun, at that point of time, we have less time to cover this area. And when we are away from the sun, we have more time to cover this area. And this particular thing is already explained, Kepler's second law. All planets sweeps equal area in equal interval of time. Q equal area in equal interval of time, because when we are close to something, the gravitational force of attraction will increase, orbital velocity will increase. Simple example, satellite. Polar satellites are closer to the sun. Polar satellites are closer to the Earth. That's why their orbital period is say 100 minutes only. But geostationary satellites, which are at 36,000 kilometers away from the Earth, it has orbital period of 24 hours. यहाँ देखो 100 मिनट है, because it is at say 1000 kilometers. अब देखो ये ISS, International Space Station, it is at 4000 meters only, and it is having orbital period of some 90 to 100 minutes. This is the orbital period for ISS. It's okay. For a geostationary satellite, which is at 36,000 kilometers, it has orbital period of how much? 24 hours. So distance matter. If you are close to something, gravitational force is more, and to counter that, you increase your orbital velocity so that you can basically counter its gravitational force. Okay. So these variations of the, here we can see that there is a variation. This variation is all because of eccentricity, obliquity, and tilt. Since it is all of them is having different like cycles, length of cycles. So yeah, that's because of that. Now we have another question over here for you. Which orbital configuration would be the best to melt an ice sheet in the northern hemisphere? Now this particular thing is already explained. I want answer from your side. So pause the video and give me the answer. Pause the video and give me the answer in the comment section. Okay, so here we want what? Best configuration to melt the ice sheet in the northern hemisphere. So no doubt, to melt the ice sheet, first of all, we should be close to the sun so that the radiation will be more. So closest is A, B and D. Now just leave these two options. We have B and D, high tilt angle and low tilt angle. In a case of high tilt angle, we know seasonal contrast will be more, and we need less seasonal contrast for grow of ice sheet. अभी हम लोग डिस्कस किए थे. So what we want is, we want high tilt angle, so the seasonal contrast will be more, and if the more seasonal contrast, less ice will form, so melting will be occur. Is this clear? To melt an ice sheet, it would be helpful to have hotter than average summer in the northern hemisphere, a high tilt angle, plus having a northern hemisphere summer solstice on 21st of June occurred at a point on the Earth's surface where the orbit is closer to the sun, At that point of time, the summer is more hotter than the average. Okay, there is higher contrast in the season, and so this will help to melt ice sheets. Okay, that's why we have interglaciations. Interglaciation mein this will enhance during glaciation period. This will enhance. So now you know why there are formation of glaciers and why there are some glaciation periods, why there are some interglaciation periods. Got it? This thing is already discussed. Okay, now here we can see that one more thing. This global temperature graph and CO2 graph is now more or less same. Both are following the same trend. Why it is so? Are you getting or not? Here we have this global temperature denoted by this color, and atmospheric CO2 is denoted by this orange color, and it is following the same trend. Why? See, we know that this carbon dioxide is a greenhouse gas. It traps outgoing radiation which is emitted by the Earth's surface. If there is no CO2, if there is no greenhouse gas, the entire emitted radiation will move back to the space. But this CO2 is acting like a say blanket. So it is holding the temperature, and over a period of time, this holded temperature, this observed radiation which is emitted by Earth's surface is slightly increasing in the Earth atmosphere. धीरे धीरे increase कर रहा है. Now if there is more observed radiation, it will again re-radiate back. So देखो CO2 जो observe कर रहा है emitted IR radiation को, again those CO2 molecules re-radiate back to the Earth's surface, and that will increase the Earth's temperature. If the Earth's temperature will increase, what happened to the Earth's glacier? It will simply increase the global temperature. Okay, if there is an increase in global temperature, ocean will become warm. We know that warm water has less dissolution property, so there is less dissolution of CO2. गर्म पानी में CO2 will less dissolve. Okay, we know Coca-Cola, when it is cold, we feel that fizz effect. Why? Because here CO2 is dissolved when it is cold. गर्म Coca-Cola पीने पे वो मज़ा नहीं आता, fizz effect नहीं आता, because now CO2 is moving away from the surface. There is no more carbonic acid. Carbonic acid is what? H2CO3. It is no more dissolved. So that fizz effect is not there. Okay, so similarly, when ocean becomes warm, we know that the CO2 is start moving away from the ocean surface, moving towards the atmosphere from the oceans. Oceans are the biggest sink of CO2. Oceans नहीं होंगे तो जितना CO2 हम लोग प्रोड्यूस कर रहे हैं, इसका मैक्सिमम पार्ट, okay, more than 70% is basically absorbed by the oceans. तो ये CO2 एटमॉस्फेयर में जाएगा. This CO2 will now basically what happened? It is a greenhouse effect. It will create greenhouse effect. So it will absorb the emitted radiation by Earth's surface, right? And the global temperature will rise. In this way, the global temperature will rise. Is this clear? So this is called CO2 amplifying feedback effect. Okay. So यहाँ देख रहे हो ना, एक चीज़ के टेम्परेचर बढ़ने से CO2 बढ़ रहा है, and thus the CO2 increase in CO2 will leads to increase in greenhouse effect. It will leads to global temperature increase. If there is an increase in global temperature, it leads to again increase in temperature of ocean surface. It will leads to increase in temperature of ice sheets. So ice sheets will melt. If the ice sheet will melt, there is less reflection. Less reflection means more absorption. More absorption means again increase in the temperature. So it will act like a chain reaction. Okay. Now here, no atmospheric CO2 value is like today's over at least past 8,000 years. 800,000 years you can say. 800,000 years में अब देखो ये 800,000 years का डेटा ही क्यों यूज़ कर रहे हैं? बिकॉज द ओल्डेस्ट आइस कोर वी हैव is having age of 800,000 years. So whenever the snow deposits over the high latitude region, high altitude region, ये अपने साथ CO2 के molecules को भी लेके जाता है. Okay, due to the overlying pressure, the CO2 is entrapped in the snow, and this snow will turn into foam, then finally turn into the ice. So this old CO2, जो geologic past के even million years, you can see 800,000 years old CO2 is still entrapped in those ice cores, and those CO2s right now when we melt that this thing, those ice cores, तो हम लोग जब उसको मेल्ट करते हैं तो वो CO2 निकल जाता है. एंड इन दिस वे वी कैन स्टडी द पास्ट जियोलॉजिक गैसेस, विच ट्रेस एलिमेंट्स आर देयर, विच गैसेस आर देयर. तो हम लोगों ने उसका जो रिकॉर्ड निकाला है CO2 के कॉन्सेंट्रेशंस का ओवर 800,000 ईयर्स. Currently the CO2 pattern is much higher. It is moving this way. Okay, पिछले 8 लाख सालों में ऐसा नहीं हुआ है. The current concentration is very high. And why this is so? Because in past 800,000 years we are not there. Okay, हम लोग recent क्या है ना, so we are the one जिसने like we did deforestation, we start burning coal, fossil fuels, industry set up and all. It all produce CO2, and this additional CO2 is moving into the atmosphere, and that's why the concentration over a current time is much more higher than in past 800,000 years. This is the reason. Okay, so here we have test for you. So I'm not going to discuss these questions. This is very easy. It's for you only. Start solving the questions right now. Give your answer in the comment section. I'll be waiting for you, and I will give you a heart to your answers if every answer will correct. So yeah, that's it for the today. If you like the video, please share and subscribe the video. And we are having offer right now on our channel, that is www.earthoholicacademy.com. please check this out right now. Massive offer is going on. Okay everybody.